Welcome to Study Loop.
So here is the given information. Our null hypothesis is that our population mean is greater than or equal to 80. Our alternative hypothesis is that our population mean is less than 80. We have a sample of 100, a population standard deviation of 12, and we are comparing our p-values to an alpha value of 0.01. So the first thing we have to do is compute the test statistic for each of the sample means that we're given. And the first one we're going to start off with is a sample mean of 78.5. So because our n is 100, it is large enough that we can do a z-test. So we'll compute a z-test statistic. And to do that, we will take the sample mean minus the population mean over the population standard deviation divided by the square root of the sample size. And for us, that is 78.5 minus 80 over 12 divided by the square root of 100. 78.5 minus 80 is negative 1.5. 12 divided by the square root of 100 is 1.2. And negative 1.5 over 1.2 is equal to negative 1.25. So we end up with a z-score of negative 1.25. Now, because our z-score is negative 1.25, we want to compare that. We want to compute a probability value, a p-value, so that we can compare it to our alpha of 0.01. So what does this p-value tell us? It tells us the area under our z-score here, z equals 1.25, our z-score to the left of our z-score under the area of the curve, okay? So we're finding this area right here. What is the probability that z is less than or equal to negative 1.25, okay? And we get a p-value of 0.106, okay? So because we have a p-value of 0.106, we're going to compare it to an alpha of 0.01. 0.106 is much greater than 0.1, so we fail to reject the null. Okay, so now if we go to part B, we are doing the same thing with a sample mean of 77. So our z-score is equal to 77 minus 80 over our population standard deviation of 12 divided by our sample size of 100. This is equal to negative 3 over 1.2, which is equal to negative 2.5. Negative 2.5. Let me just check I am doing this right. Yeah, it is negative 2.5. So we have a z-value of negative 2.5. So if we draw our normal distribution here with a z-value of negative 2.5, we're finding the area to the left of negative 2.5 and underneath this curve. Probability that z is less than negative 2.5. So that's our p-value. So our p-value is equal to 0.006. And now we're going to compare our p-value of 0.006 to our alpha of 0.01, and 0.006 is less than 0.01. So we have sufficient evidence to reject the null hypothesis, okay, at an alpha of 0.01 and p-value of 0.006. All right. Now we're going to do the same thing for part C. Sorry. We're going to compute a Z value, which is equal to our sample mean, which is 75.5, minus our population mean, which is 80, over our population standard deviation, which is 12, divided by our population size, our sample size, which is 100. And we are going to get a value of negative 3.75. Okay, so now we're going to draw our normal distribution. A z-value of negative 3.75, if we have z equals 0 here, would be somewhere here, not 3.75. We are looking at the area to the left of negative 3.75 and under the curve. This is equal to the probability of z being less than negative 3.75. If we calculate that value, we get a alpha value, all right, of approximately 0.00001. All right. Okay, so with a p-value, so this is part C, with a p-value of 0.0001, we're going to compare that to an alpha value of 0.01, and this p-value is much less than 0.01, so we have sufficient evidence to reject the null hypothesis with a p-value of 0.0001. We can write about approximately 0.001 at an alpha of 0.01. Okay, now for the last part of the problem, part D, we're going to do the same thing we've been doing. We're going to find a z-test statistic, which is equal to our sample mean of 81 minus our population mean of 80, divided by our population standard deviation, which is 12, divided by our population size, which is 100. And this is equal to 1 divided by 1.2, which is equal to about 0.83. Sorry, exactly about 0.83. If we draw our normal distribution, we have z equals 0 here. And this is where you have to be careful. Because our z-test statistic is positive, our z value ends up being here. But we're still going to find the area to the left and underneath the curve. Now, you can see that this z-test statistic, this probability here, the probability that z is less than or equal to 0.83 is pretty big, all right? Is pretty big. So we will most likely end up failing to reject the null hypothesis. But once we get this value, our probability that z is less than 0.83 is equal to 0.797. And if we compare our p-value of 0.797 to our alpha of 0.01, we get that 0.797 is much greater than 0.01. So we fail to reject the null with p-value of 0.797 at an alpha of 0.01. Hope that helped.